So the problem I'm going to give you guys today is prove 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 all the way until 1 over n times n plus 1 equals n over n plus 1, where n is an element of all positive integers by mathematical induction. So as I said before, there's 5 steps to answer a mathematical induction problem, and basically for the first step you just restate the problem. So the symbol over here means for all elements of positive integers. Okay, so for step 2, I have to show that P1 is true. So basically I have to plug the number 1 into n. So n is going to be 1 for step 2. So step 2, show P1 is true. Okay, so now I'm going to write, so basically this 1 over 1 times 2 is P1. That's when you plug in 1. So the left side, sorry. The left side is 1 over 1 times 2. And that equals 1 over 2, which is a half. So I'm just going to write that again. And then for the right side, sorry, so now basically I have to plug in 1 for n. So over here I have to plug in 1 for n. So 1 over 1 plus 1, which equals 1 over 2, which is 1 over 2. And now you can see the right side equals the left side. So let me write that as a statement. This symbol, by the way, means therefore. Therefore, left side equals right side. Sorry, this is a bit messy, guys. And therefore, P1 is true. So I'll let you guys see that again. Okay, so for step 3, I already wrote step 3. So for step 3, I have to assume PK is true. So I'm going to write that down. Assume PK is true for K is greater than or equal to 1. So I wrote another statement, so I said assume. Wait, I'm going to underline each one that I did. So show, let's. Okay, so basically now I'm plugging in K for n. So I'm just replacing the variables. So I'm going to write the question down again. So 1 over 1 times 2 plus 1 over 2 times 3 plus all the way until 1 over. Okay, so now as you can see over here it was 1 over n times n plus 1. But right now I'm just going to plug in K for n. So 1 over K times K plus 1, which equals, and here it said n over n plus 1, so now I'm just going to plug in K for n. So K over K plus 1. K over K plus 1. And this part, this whole thing, so let me underline that for you. That's PK, because I said assume PK is true, so this is PK. This is not going to be labeled as PK. Okay, so as I mentioned before, step 4 is the hardest. So to start off step 4, I'm going to show PK plus 1 is true. So I'm going to write down my goal, and basically I'm replacing K with K plus 1. So I started off by writing 1 over 1 times 2 plus 1 over 2 times 3 all the way until 1 over K times K plus 1, which was everything from step 3. But then I put K plus 1 into K. So I substituted K plus 1 into K. So I said 1 over K plus 1, which was this K, and then times K plus 1, which is that K, plus 1. And then that equals, and I put K plus 1 into K again, so K plus 1 over k plus 1, which is here. Then I wrote that line down again, and because I put k plus 1, I simplified that to k plus 2 for this and that. Okay, so now I'm going to write everything from the left side. So the left side is 1 over 1 times 2 plus 1 over 2 times 3 plus all the way until 1 over k times k plus 1 plus 1 over k plus 1 times k plus 2. Okay, and now if you see from step 3, which is here, pk is all that, right? So I'm just going to write that down. So this part here, from here to here, is pk. So from here to here is also pk because it's the same thing. And now, because that's pk, from step 3 we found out that pk is all that, which equals k over k plus 1. So now I'm going to write k over k plus 1 plus that, which isn't part of the pk, plus 1 over k plus 1 times k plus 2 has to somehow, after simplifying and distributing and all that stuff, this stuff has to somehow become k plus 1 over k plus 2. Okay, so now I rewrote this onto a new sheet of paper because I'm running out of space. So that's over here. Yeah. So basically from this, you can tell that the LCD, which is the common denominator, lowest common denominator, which is k plus 1 times k plus 2. So now by distribution, I can expand the top. Okay, so now this quadratic has to multiply to 1. So this is a method that my teacher taught me, MA, which is multiply and add. So this quadratic has to multiply to 1 and add to 2. So basically, 1 and 1, k plus 1 and times k plus 1. So 1 plus 1 adds to 2, and 1 times 1 is 1. So that's the way to factor this quadratic. And then over k plus 1 times k plus 2. And as you can see here, there's 2k plus 1, so these things can cancel out, which leaves me with k plus 1 over k plus 2. And that equals the right side from before, from the previous page, as you can see, which was k plus 1 over k plus 2, which is right here, right over here. K plus 1 and over k plus 2, which means the left side equals the right side, and therefore pk plus 1 is true. Okay, so for step 5, which is the final statement, so I'm going to write step 5. This symbol means since. So since P1 is true, and P1 is true because we figured that out from step 2, which was here. So since P1 is true and PK, this arrow means implies. So far we have since P1 is true and PK implies PK plus 1, PK plus 1 is true, then Pn is true for all elements of real integers. So let me read this out for you. So this is basically saying, since P1 is true and PK implies that PK plus 1 is true, Pn is true for all real elements of integers. So that's the final step.